really old etchant. It took 3 baths in about 3 hours, and the traces were having prunes. And the board didn't come out very well, which is probably why this one doesn't really function. When you put it in the water, yes, the high voltage traces begin to electroplate onto the low voltage traces. After several years, it will short out. In salt water, not terribly long. In a pool, 30 minutes, no problem. Once again, keeping an eye on the mission, we can see that there are much fewer problems than are necessary. That allows me to put all the control electronics and all the power on a really tiny body. So all I need is this. In fact, I can strip off the outer, just use this, and have a very lightweight tether mobility. Now, it's going back to the old ROV in a box 3-motor design. So it's not as maneuverable as big aluminum. But you can still do the differential on the motors to turn in place. Still have the vertical to go up and down. The one thing that's not on there yet is the nifty little gripper that I've been working on. This one is from scratch. A couple of days ago, this was a sheet of Lexan. And I'm still trying to get a way to clamp these together onto a nut on a rotating threaded rod with a little tiny brushed DC motor to drive it. That way I eliminate the problem of trying to get a servo to work underwater, which has the same problem as the camera. The electronics inside the servo, low current parts. The motor and the rest of it probably can be flooded. So probably instead of sealing the box on a servo, you want to take it apart, cast the electronics in acrylic, put it back together again, and see if the resistor is enough to keep it going. You might be able to get a servo that works well. But to avoid that in this one, I have a threaded rod drive. We'll move a screw up and down, and we'll open and close the gripper to be able to grab devices. I'm hoping to be able to build a quad gripper with a base and another cheap toy motor with plastic gears, lots and lots of gears, turns very slowly. We'll turn the entire base as the wrist, around and around and around to turn the winch in order to be able to pick it up, pick up the RV. Now, this is probably not much bigger than the winch. When I start turning something like this, we may not have enough vertical stability. So there's one reason for having a multiple mini ROV project. If I have one that has the wrist motor and 2 that come in from the side and grab the battery holders, I make what in boating terms is called a raft with much bigger horizontal stability in order to have enough to be able to turn the winch and pull it out. And in the meantime, they can go separately, retrieving, fixing, moving, accessing devices separately at a much higher rate of speed. Power consumption, 4 AA batteries, 1 4-amp fuse, 48 watts. You can have a lot of these in the water for the power requirement alone. Now at the other end, the part that I've never been able to get to work on the big one, this is an ROV drive station. It's another microcontroller chip, which I do know how to program. And instead of USB joysticks, which I'm still trying to figure out how to read into programs so I can convert into motor commands to send down the serial port to tell this one what to do, it's very easy to read analog values, do a little bit of math, convert it into a serial string and send it down. This is already programmed, ready to go. All I need to do is to take off the temporary serial port and solder on these lines. And solder in a little plastic battery holder to provide the power, 3.5 volts. connection here for where the camera signal comes out, pigtail to have the video for the group. Another version of this has a third joystick on it. This one is forward and reverse, side to side, differential on the first two motors. The second one, forward like an airplane, goes down, pulls back like an airplane, goes up, left and right, open and close the gripper. Thinking on the right-hand side of the gripper, that's the way you want the right-hand side to go. So very simple control logic. On the wrist, it requires a fifth analog input, so there'll be one more joystick just to be able to control the speed of rotation, and then an unused channel. And in fact, these are double motor drivers, so there's always 6 channels available. The PWM is generated in software. The Atmel only generates 6 PWM channels in hardware. And by eliminating the direction in PWM, the direction normally went to an inverter and then some AND gates and the PWM channels in order to generate just forward PWM and the rear PWM. I had to pins 12 separate PWM channels to run 6 devices, no external gates devices, chip count of 3. Uses the internal oscillator, so it takes a little bit of tweaking to get the poolside device and the underwater device to exactly sync up. Then they're welded to a cable together because this is small enough to go on the carrier. And you're done. You want to build that extra. Total cost estimated for 3 of them was $270. I spent a great deal more than that, but that's technically what actually is required to provide 3 running ROVs with grippers and surface stations. So by thinking well outside the box, I've thrown away so many problems. Creative freedom. Turns out that when we went from the cast grouping here where they're all soldered together to using the pre-made, the $1.90 battery holders don't stand up very well, particularly after they've been crammed at the end and then PVC cement has sealed around them. They tend to kind of fall apart and lose connection. Still trying to figure out why this guy doesn't want to talk to me. Probably just going to pull the board and replace that and make this one a spare. I've gone to slightly bigger motors to get slightly more speed and slightly bigger pieces, so the final version is about 20% bigger. But basically, it's almost as close together as the propellers allow. And no airtight container for the electronics. No need to worry about making a airtight cable pass-through, power pass-through, motor drive pass-throughs. There is a temperature sensor here, so I can sense the temperature, and that comes back up the serial bus. Currently, I don't have a way of displaying it, so it may not get used. But a number of sensors can be placed on there that directly sense the water it's sitting in, with no need to worry about through-hole penetrations in order to get the signal in and out. So it greatly simplifies the process. This has almost no nuts and bolts and connectors on it. There are connectors on the camera because it's a high-risk item. It's most likely to actually, develop a leak and go back. So it's easiest to undo that one and replace another one. The rest of it, solder joints, take only a little bit more time than water-resistant connectors. So why not just solder it in and be more reliable? Okay, any questions?